In the depths of the cosmos, stars live, die, and are reborn in spectacular fashion. Picture, if you will, the vast expanse of the universe. It's a realm that stretches out in all directions, seemingly without end. It's a place where time and space intertwine, where the laws of physics are both our guide and our mystery. Within this cosmic tapestry, there are millions upon millions of glittering stars, each a world unto itself. These stars are not just distant points of light, they are a testament to the universe's boundless creative energy. Each star we see is a cosmic crucible, a place of extreme heat and pressure where elements are forged. And each star, no matter how bright or dim, is on a journey. Now let's pull back the celestial curtain and explore this journey in detail. The life cycle of a star is a process that spans billions of years. It begins with a cloud of dust and gas, condenses under gravity into a fiery sphere, and then, after a long and luminous life, ends in a dramatic and violent death. But this death is not a final act. Instead, it heralds the birth of something new, something extraordinary. And the most spectacular of these stellar deaths is the supernova, a cosmic explosion of such scale and intensity that it outshines entire galaxies. A supernova is more than just a spectacle. It is a key player in the cosmic drama, a creator and destroyer in equal measure. It disperses elements across the universe, sowing the seeds for new stars, new worlds, and perhaps new life. So as we stand on the precipice of this cosmic journey, let's pause for a moment. Let's marvel at the grandeur of the universe, the beauty of its stars, and the incredible forces that shape them. To truly understand the grandeur of a supernova, we must first delve into the life of a star. Let's embark on this journey together as we explore the stellar life cycle, the cosmic fireworks of supernovas, and the incredible process of death and rebirth in the cosmos. Stars, much like living beings, have a life cycle. They are born, they live, and they die, their existence playing out on a cosmic stage. But where does this cycle begin? The birth of a star is a process of epic proportions, a celestial ballet of gas, dust, and gravity. In the vastness of space, pockets of gas and dust coalesce. These are the building blocks of stars, the raw materials from which they are formed. But how does this transformation occur? The answer lies in a process known as gravitational collapse. Gravitational collapse begins when these pockets of gas and dust, also known as nebulae, start to contract under their own gravitational pull. This process can be triggered by a variety of factors, including the shock waves from a nearby supernova or the close passage of another galaxy. As the nebula contracts, it begins to spin and flatten into a protostellar disk. The center of this disk, where the majority of the mass is concentrated, heats up due to the intense pressure. This central region, now a hot and dense protostar, is the heart of the forming star. However, becoming a star is not as simple as just heating up. There are conditions that must be met. The protostar needs to reach a temperature of about 10 million degrees. At this scorching heat, nuclear fusion can occur. Hydrogen atoms in the core of the protostar start to fuse together to form helium, releasing a tremendous amount of energy in the process. This energy counteracts the gravitational pull, preventing further collapse. The protostar has now ignited and become a main sequence star. This process, from nebula to star, can take millions of years. It's a slow, gradual journey, a testament to the vast timescales on which the universe operates. After millions of years, the star reaches maturity, not too dissimilar from how we humans grow. It has completed its birth, and now begins its stellar life, burning brightly in the darkness of space. Just as we continue our journey after adolescence, so too does the star, ready to play its part in the grand cosmic drama. A star's life is a constant battle against gravity. Picture a celestial ballet where our star, the prima ballerina, isn't just twirling in space by chance. No, it's gravity that's calling the shots, the puppet master pulling at the strings of our star, urging it to implode under its own weight. But our star is a fighter. It refuses to bow down to the relentless pull of gravity. Instead, it finds a way to maintain its balance, its form. And it does this through a process as old as time itself, nuclear fusion. Within the star's core, a fiery furnace rages, converting hydrogen into helium. This process isn't just about transformation, it's a process of liberation. Energy, vast amounts of it, is released in the process. Now you might be wondering why all this fuss about nuclear fusion? Well, it's this very process that allows our star to resist the pull of gravity. The outward pressure created by the energy released from fusion balances the inward pull of gravity. It's a delicate dance, a tug of war between two mighty forces. And it's this balance that dictates the star's life. This energy released by nuclear fusion isn't just crucial for the star's survival. It's the lifeblood of the universe. The light we see from stars, the warmth we feel from our sun, it all comes from this energy. It's nuclear fusion that makes stars the radiant, glowing orbs we see in our night sky. But, as with all things in life, nothing lasts forever. Our star, like all stars, is burning through its fuel, converting hydrogen into helium, and with each passing second, the hydrogen supply dwindles. The star's fight against gravity becomes more desperate, more intense. But what happens when the fuel runs out? What happens when the star can no longer resist the relentless pull of gravity? That, dear listeners, is where our story takes a turn, leading us to the death and rebirth of stars. But that's a tale for another scene. The death of a star is as spectacular as its birth. A star's demise is a fascinating event, played out on a cosmic stage unfolding over millions of years. The key player in this celestial drama is nuclear fuel. You see, stars are essentially nuclear reactors, producing light and heat by fusing hydrogen atoms together to form helium. This process is called nuclear fusion, and it's what keeps a star shining bright. But even the most colossal stars have a finite supply of fuel. Once a star exhausts its nuclear fuel, it can no longer produce the energy needed to counterbalance the force of gravity pulling inward. The star begins to collapse under its own weight, a gravitational pull that squeezes the core, causing it to heat up. As this pressure mounts, the star's core grows denser and hotter until finally, it can't withstand the pressure any longer. This triggers a violent explosion, a supernova. The star's outer layers are blown off into space, lighting up the cosmos with a brilliance that can outshine an entire galaxy. This is no ordinary explosion, mind you. The energy released during a supernova is so immense that it can be seen from billions of light years away. The explosion is not just a grand finale, but a catalyst, a creative force that triggers the birth of new stars and galaxies. Yet, the star's core, the heart of the explosion, survives. It either forms a neutron star or collapses further to become a black hole, depending on its original mass. These remnants serve as cosmic tombstones, marking the places where once mighty stars ended their stellar journeys. So the death of a star is not just an end, it's a transformation, a metamorphosis from a shining beacon of light and heat to a dark, dense object of intense gravity. This marks the end of a star's life cycle, but it's not the end of the story. The death of a star is just another chapter in the ever-evolving narrative of our cosmos, a tale of birth, life, death, and rebirth played out on the grandest scale imaginable. Supernovas are the universe's grandest fireworks display. Have you ever wondered what happens when a star, having exhausted its nuclear fuel, finally gives in to its own gravity? The answer is a supernova, an astronomical event that outshines an entire galaxy, making billions of stars appear dim in comparison. Imagine, if you will, the energy of 100 octillion nuclear bombs exploding at once. That's a 1 followed by 29 zeros. This staggering amount of energy is what a supernova releases in a mere matter of seconds. It's a spectacle of cosmic proportions, a luminary performance that lights up the universe in an awe-inspiring display. Now, supernovas aren't all the same. In fact, there are two main types of these celestial powerhouses. The first is a core collapse supernova, which occurs when a massive star, much larger than our sun, exhausts its nuclear fuel. The core collapses under its own weight, and the star's outer layers rush inward, resulting in a massive explosion. The second is a type Ia supernova, which involves a binary star system. Here, a white dwarf pulls material from a companion star, accumulating mass until it reaches a critical limit. The result? An explosion so consistent in brightness that astronomers use these supernovas as standard candles to measure distances in the universe. Whether a core collapse or a type Ia, each supernova is a cosmic spectacle, a stellar swan song that outshines everything in its vicinity. But it's not just about the grand display. These explosions are also cosmic factories, forging heavier elements like gold, silver, and uranium in their fiery crucibles. As we delve into the mesmerizing world of supernovas, we start to understand their significance. They're not just the universe's grandest fireworks display. They're also a key player in shaping the cosmos as we know it, birthing new stars and even black holes from their explosive remains. But why are these celestial explosions so important? Well, that's a story for our next scene. Stay tuned. Supernovas are not just cosmic spectacles, they are the architects of the universe. Imagine a celestial architect, creating and destroying in equal measure, shaping the universe in its explosive wake. That's the role of a supernova. When a star, significantly larger than our sun, exhausts its nuclear fuel, it collapses under its own gravity and then rebounds in a massive explosion. This dramatic event is not just an end, it's also a beginning. You see, in the crucible of a supernova, elements are forged. The tremendous energy released in the explosion drives nuclear reactions, creating new elements heavier than iron, something not possible under the normal life of a star. Gold, platinum, uranium, and other heavy elements, the very materials that make up our world and us, are all born in this cosmic forge. But these newly formed elements don't just sit idly in the remnants of the exploded star. The shockwave of the supernova disperses them across the universe. Like seeds sown by a cosmic farmer, these elements travel through space, eventually becoming part of interstellar clouds. And it's within these clouds that the cycle of stellar life begins anew. Under the pull of gravity, these clouds contract, heat up, and form new stars and planetary systems. The iron in our blood, the calcium in our bones, the oxygen we breathe, they all have their origins in supernovas. We are quite literally stardust. However, the influence of supernovas extends beyond the creation of elements. The energy from supernovas can trigger the formation of new stars. Their remnants can produce pulsars and neutron stars, and in extreme cases form black holes, further adding to the cosmic architecture. So while supernovas represent the death of a star, they are also agents of creation. They are a testament to the universe's constant cycle of death and rebirth. The elements they create and disperse serve as the building blocks of the universe, forming stars, planets, and even life itself. In essence, supernovas are the universe's recycling system. From the ashes of a dead star, new celestial bodies are born. In the cosmic ballet of the universe, the end is merely a prelude to a new beginning. The death of a star, as violent and explosive as it may be, is not merely an end, but a catalyst for the creation of new celestial objects. Let's delve deeper into this process. A supernova, the explosive death of a star, disperses an incredible amount of matter and energy into the cosmos. This stellar debris, rich in heavier elements, is spread across vast distances, mingling with existing interstellar matter. These elements, many of which are fundamental building blocks of life as we know it, coalesce over millennia, drawn together by the inexorable pull of gravity. As this cosmic dust and gas come together, they form a dense, hot core. This is the birth of a new star, a phoenix rising from the stellar ashes. But stars aren't the only celestial bodies born from this process. Planets, asteroids, and comets can also form from the remnants of a supernova, each one a testament to the star that once was. Even black holes, those enigmatic devourers of light and time, can be the result of a supernova. If the dying star was sufficiently massive, its core collapses under its own gravity, creating a singularity, a point in space where the pull of gravity is so intense, not even light can escape. Our very own solar system, too, was likely born from the remnants of a supernova. The elements found on Earth, in our bodies, in the air we breathe, they were all forged in the heart of a dying star. We are, in the most literal sense, stardust. So, in the grand scheme of the cosmos, supernovas signify both an end and a new beginning. They are the cosmic crucibles where elements are forged, and from their fiery demise, new stars, new planets, new systems are born. In the dance of the universe, death and birth are intertwined, a cycle as old as time itself. The cosmos is a cycle of birth, death, and rebirth. It's a perpetual dance of creation and destruction, a rhythm that resonates throughout the universe. Stars are not just twinkling lights in the night sky, they're the heartbeats of the cosmos. They are born, live, and die, much like us. Supernovas, the spectacular death throes of stars, play a pivotal role in this cosmic cycle. They are the universe's recycling centers, taking the remnants of dead stars and creating the building blocks for new celestial bodies. In a sense, every atom in our bodies, every speck of dust on this planet, has had a journey through the heart of a star. These celestial events are not just beautiful to behold, they are integral to the very fabric of the universe. So the next time you gaze at the night sky, remember, you're witnessing a cosmic ballet of life, death, and rebirth.